Here in this video, we're going to look at the slope of a line, and we're going to define the slope as the change in your y, and we're going to write that as delta y, okay? And the little triangle here, this is red, delta y simply means your change in your y, and then that's divided by delta x, which is the change in our x. And sometimes you may hear this referred to as the rise over the run. The rise because that's your y, which is going up and down, and the change in the x, which is the run, which is going left and right. So the slope is simply looking at, as your y changes, what is the change in your x? And if we're given 2 points, for example, x sub 1, y sub 1, and another point, we'll call that x sub 2, y sub 2, and the little sub numbers just tells us that we're looking at 2 different points here. So we have 2 points on the line, and the slope, which is m, this stands for the slope, is going to be the change in the y. So we're going to simply subtract the y coordinates, and you'll see that as y2 minus y1 over x2 minus x1. Now, it doesn't matter. You could actually set this up and subtract in the other order. Most of the time, you're going to see the formula as y2 minus y1 over x2 minus x1. It doesn't matter which point we call x1, y1 or x2, y2. We certainly could subtract this in the opposite order, but you have to be consistent. So we could have said y1 minus y2, but then on the bottom, we'd have to have x1 minus x2. This is the way that you're typically going to see the formula, but either way will give you the same answer for the slope. So let's look at an example. If I give you the following 3 points, 1, 0, 5, 6, and -1, -3. So if we plot the points, we have 1, 0, so that's over 1. There's our point, and then we go 5, 6 is over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6. And our third point is -1, and then down 1, 2, 3. And we can draw a line through all 3 of these points. So now, if we want to find the slope of this line, well, one option is we can certainly just pick 2 points, and we can pick any 2 points on the line. Now, you probably want to pick a nice point that we have plotted here where it crosses, and we can tell this is at 1, 0, and we know this point over here is at 5, 6. And we could certainly just calculate what is the change in our y. Well, we can count up 1, 2, 3, 4, 5, 6. So the change in our y is 6 as we go from this point to the point up here at the top. And then we got to count over what is the horizontal change. The change in our x would be 1, 2, 3, 4. So there we would have our slope is 6 over 4, and we know we can reduce the fraction, and we could divide by 2, so that would simply be 3 over 2. So that is the slope of this line. Now, you want to leave your slope typically as a fraction. We don't want to rewrite this as a decimal, so leave it in a fractional form. Even though this may be an improper fraction, that is fine. Now, if you notice, if we were to start at this point and use 3 over 2, then we could certainly have counted up 1, 2, 3. And then if we count over 2, notice we still end up with a point on the line. And that's because it doesn't matter which 2 points you pick on the line. As you go from one point to another point, your slope is always going to be equal to 3 over 2. So if you notice here, from this point, we could count up 1, 2, 3 again, and then over 2. So we still end up with 3/2. For an example, we could even go down here to the very bottom, and starting at this point, if we were to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go over to the point, that would be 1, 2, 3, 4, 5, 6. So we're going over 6. So notice there then we have the rise is 9, the run is 6, and again that reduces to 3/2. So it does not matter which point you pick, it will always be the same slope. Now, that's easy enough. Now, if we don't have nice numbers that fall where we can easily calculate the slope, then we can use this particular slope formula, y2 minus y1 over x2 minus x1, which has given us the slope. So if we were to pick 2 points, well, we have the 2 points here, so I want to use the point 1, 0 and the point 5, 6, and we can find the slope. And if it's helpful, you may want to label, for example, you may want to label here, this is x1, this is y1, and I'll call this one x2 and y2. So then if we plug this into our formula, y2, which is 6, minus y1 is 0, and then x2 is 5, and x1 is 1, so that's 5 minus 1, and notice we get 6 over 4, which again simplifies to 3/2. So we can look at the graph and estimate the slope, or we can actually find 2 points, and then using this slope formula, we can calculate the slope by subtracting your y values and dividing that by subtracting your x values. All right, now here I want to look at 2 different parts of slope. We have what's called a positive slope and a negative slope, and that's going to tell us the direction that your line is going. So for example, if we start here and we have, let's say, the points 2, 3, and 5, 4. If I plot the points over 2 and up 1, 2, 3, and then if we go over 5 and up 4, so 1, 2, 3, 4, 5, 1, 2, 3, 4. And if I draw a line through here, here's our line. And notice that this line, if you were to think of reading this like a book, if you go from left to right, this line is going up. So what that tells us is that we're going to have a positive slope. So if we were to calculate the slope, we know that it should be positive. In other words, if we got a negative answer, we know that we've done something wrong. So once again, if we plug this into our formula, then again, I'm going to label this as x1, y1, and this would be x2, y2. Then we could take 4 minus 3 divided by 5 minus 2. So we end up with 1 over 3. So here the slope is 1/3. And you'll notice that if we go up 1 and then over 3, that is certainly the slope of the line. And again, anytime your line is going from left to right, just like you're reading a textbook, if it's going uphill, it's going to always have a positive slope. Okay, now let's look at an example of a negative slope. So if I'm given the 2 points, let's say that we have the points 1, 1, and 5, negative 2. If we plot those points, we're going to go over 1 and up 1, and then over 5 and down 2. So then if I connect these 2 points, here we have our straight line. And if we want to find the slope, just like we've done before, then if I call this x1, y1, x2, y2, then our slope is going to be the change in the y value, so that's negative 2 minus 1 over 5 minus 1. So negative 2 minus 1 is negative 3, and then 5 minus 1 is 4, and we have a slope of a negative 3/4. So that means if I was to start at a point on the line, let's say here, and I could count down 3 because it's negative, so that's 1, 2, 3, so that's negative 3, and then to the right 1, 2, 3, 4, so we have our slope of negative 3/4. Now I do want to point out what would happen if we subtracted the other direction. In other words, what if I would have said 1 minus a negative 2? Well, 1 minus a negative 2, then we would have 1 minus 5. And notice now we have 1 minus a negative 2, so that's 1 plus 2, which is 3, and 1 minus 5 is a negative 4. So we still get a negative 3/4. And you may ask, does it matter that the negative is with the 4? Well, remember, for a fraction, it doesn't matter where we put the negative, whether it's on top or on the bottom, it's still a negative 3/4. So if I was to start at this same point here, then the 3, if we think of the 3 as being positive, then we could count up 1, 2, 3. So that's a positive 3. And then the 4 is negative, and we would count 1, 2, 3, 4 to the left. And notice we end up with a point on the line. So it doesn't matter which number we take the negative with, whether it's the y or the x on the bottom. Either way, you're going to still have the same slope of the line. And you'll notice over here, if we did the same thing with the positive slope example, again, we could switch the order and we could say 3 minus 4 on top, and then 2 minus 5 on the bottom. And 3 minus 4, we get negative 1. 2 minus 5, we end up with a negative 3. And notice here, you wouldn't want to leave this as negative 1 over negative 3, because two negatives divided would be a positive 1/3. Now, if you wanted to count this off, you could, as far as if you started here at this point and said, oh, it's negative 1, we could go down 1, and then we could count to the left 1, 2, 3. So if they're both negative, notice we're still going to end up with another point on the line. But as far as the answer, you'd want to leave your answer as a positive 1/3. You don't want to write it as negative 1 over negative 3. So from all of this, you're going to always have a positive slope if your graph is going uphill as you go from left to right, and you're always going to have a negative slope as your graph goes downhill from left to right. So if you ever look at the graph and your slope, make sure that they make sense. If it's uphill, you better have a positive slope. If it's going downhill, your slope better be negative, or you've made a mistake somewhere. All right, now we're going to look at an example of what's going to happen if we have a horizontal line such as y equals 2. Now what that means is x can be any number. If we were kind of making our little x and y chart here, what that means is it doesn't matter what our x value is, whether it's 0, 1, 2, 3, or negative 1, our y value is always going to be equal to 2. So if you have an equation y equals 2, then it doesn't matter what your x is, y is always 2, so therefore you're going to have a horizontal line at y equals 2. Now, what is the slope of this line? Well, we could easily calculate this if we were to pick 2 points, and I'm going to go ahead and pick 1, 2, and 3, 2. So if I use the points here 1, 2, and 3, 2, so let's see, 1, 2, and 3, 2, and if I plug them into our formula, okay, so x1, y1, x2, y2, we're going to end up with 2 minus 2 on top and 3 minus 1 on the bottom. So we have 0 over 2, which is equal to 0. So you notice your slope is going to be 0. And that's because, notice, to go from one point to the other, do we ever have to go up? All we're doing is going 2 units to the right. So therefore, we're not having to go up. So that means the change in our y value is 0. And it doesn't really matter what the change then is the x, because if you have 0 divided by a number here, 0 divided by 2, 0 divided by 3, it's always going to be equal to 0. So for any horizontal line, your slope is always 0. And that's because there is no change in your y. And if that y is 0 on top, then 0 divided by a number will always be equal to 0. So the other possibility is, what happens if we have a vertical line such as x equals 3? And basically what that means is, if we were to have a little xy chart again, that means that no matter what your y value is, whether it's -1, 0, 1, 2, your x value is always going to be equal to 3. So if I was to pick two of these points, let's say that we pick 3, -1 and 3, 2, then we're going to go, let's see if it's a vertical line at x equals 3. So 1, 2, 3. Here's our vertical line. And if we pick 3, -1, and then 3, 2, there's our 2 points. And if we want to find the slope of this line, then we're going to have 3, -1, 3, 2. And again, if it helps you, you can label x1, y1, x2, y2. So therefore, your slope is 2 minus -1. Be careful with the negatives. It's 2 minus the -1 over 3 minus 3. So 2 minus the -1 becomes 2 plus 1, so that's 3 over 0. And what is 3 over 0? And I'm hoping you do not say 0. Hopefully you remember that we cannot divide by 0, so this is considered to be undefined. So your slope is undefined. And that's because if you notice, to go from one point to the other, there is no change in our x, there's only change in the y. So therefore, you're going to end up with 0 in the denominator, and we know we cannot divide by 0, so therefore the slope is undefined. So anytime you have a vertical line, your slope is always going to be undefined. So you really won't have to go through all these steps. I'm just trying to show you mathematically why the slope is undefined when your line is vertical, and why your slope over here is equal to 0 when your line is horizontal. So this is true for any horizontal line and any vertical line. So keep in mind, when you're calculating slope, it's simply looking at the change in your y divided by the change in your x. And if you're given 2 points, then you're going to subtract your y values, and then you're going to subtract your x values, and then you're going to divide y over your x.